So in our previous example, we solved using elimination. Well, matrices give us a better or more condensed way of solving. So with matrices, we can turn our system into a system of matrices. We have our coefficient matrix, our variable matrix, and then our constant matrix. Notice if I multiply this out, I'm going to end up back with my system. I can then condense this further into what we call the augmented matrix. So the augmented matrix is our coefficients and our constants. Now we can perform our same row operations on these matrices. So multiply row 1 by 2, I end up with this. Subtract row 1 and row 2 and replace row 2, I get 0, 5, 10. Notice up here, I had 5y equals 10. So that's the same thing as I've got down here. 1/5, and I end up with 1, 2 in the bottom. Now, using this, I can say row 1 minus 4 row 2 gives me 206. I ended up with 5x equals 15. We've ended up with 2x equals 6. Either way, we now end up with our identity matrix and our solutions. So from this, I can infer that x equals 3, y equals 2. If I put this back into this order and multiplied it out, I would end up with the same result. We use slightly different vocabulary with talking about row operations on the augmented matrix. Interchanging two rows is called swapping. We scale when we multiply by a non-zero constant. And we pivot if we replace rows with sums of a row that's a multiple. It doesn't have to be a multiple. We could just add row 1 and row 2. So here we're summing row 1 plus negative row 2. So these are the vocabulary that we use, and it gives us a nice way to solve by hand. Similarly, we can solve in our calculators by putting in the augmented matrix and then doing reduced row echelon. Remember, you have your calculators, so use them. Use them, use them. So I'm going to do this first one with you and then leave these two for you to do on your own. So solve using elementary row operations. I'm going to go ahead and create my augmented matrix. 3, 2, 19, 5, negative 2, 5. Okay, so the first thing I'm going to do is I'm going to add row 1 and row 2, and I'm going to leave row 1 alone, and then add row 1 and row 2. So that's going to give me 8, 0, 24. So I'm going to replace this bottom row with row 1 plus row 2. Now I'm going to take 1/8 of row 2. So I'm going to scale 3, 2, 19, 1, 0, 3. Straight away I know that my x value is equal to 3. Now I'm going to multiply this by 3. Similarly, I could, instead of doing 2 steps, I can do 1 step to say row 1 minus 3 row 2. That's going to be faster for me. So 0, 2, 19 minus 9 is going to give me 10. 1, 0, 3. And I've got my augmented matrix still, so I should be drawing my line. And now I'm going to take 1/2 of row 1, and I'm going to end up with 0, 1, 5, 1, 0, 3. I can swap if I want it to be in my identity order. 1, 0, 3, 0, 1, 5. Of course, I don't really need to do that because from here I can see that x is 3 and y is 5. You always want to go ahead and make sure you check your solutions just to ensure that you didn't do anything wrong. Yeah, that should be standard any math procedure. So I'll leave these two to your own, and you can of course check the solutions online.